Hello class, and welcome to section 7.1, which is about adding and subtracting polynomials. By the end of today's lesson, you will be able to identify the types of polynomials, write them in standard form to find their degree and leading coefficient, and then finally be able to add and subtract them. Before we get into the definition of polynomial, we're going to start by just looking at a monomial. So a monomial is a number, so we could say 5, or a variable, we'll say y, or the product of a number and variables. Let's say 7a, b, c to the third power. And those variables have to have a whole number exponent. A couple extra rules about monomials. They cannot have negative exponents, and there can be no variables in the denominator. As we know from our lesson 6.1, that's essentially saying the same thing, because if I said I have x to the negative second power, that's the same as saying 1 over x to the second power, but I just have both of those up there so that you're aware that both formats are not allowed. Special vocab word, a constant is a monomial that is a real number. So at this example right here, the number 5 we would call a constant. So now that we know what a monomial is, we're going to take a minute and identify. Right here, we've got x, y, z squared over 2. We could rewrite that as 1/2 x, y, z squared. So it's a number and variables being multiplied. So this is a monomial. Next one, we have dividing by a variable. So that is not 5, as I said on that first slide. That is a monomial. It's a constant. Again, multiplying numbers and variables, that is a monomial. We've got just variables with an exponent, monomial. Negative x plus 8 is not a monomial. Addition is not allowed. It is not a singular thing. Mono means singular. J by itself, adding 24 is not allowed. And then again, dividing by a number is okay. So that's just kind of a general idea of what a monomial is and what it is not. It's important to understand what a monomial is in order to be able to understand what a polynomial is. Poly means many, so we have many different monomials. It can either be a monomial by itself, or the sum, or you could put in difference, of 2 or more monomials. So this is where adding and subtracting are now allowed. If you have a binomial, that would be like when we had negative x plus 8. That's an example of a binomial. One monomial and a second monomial being added. A trinomial could be 7x, y plus 9b plus 15. 1, 2, 3 separate parts being added. This first part is a monomial, second part, third part, or we could make one of these subtraction, because adding and subtracting are both allowed. Standard form. This happens when the terms of a monomial are written from the highest degree to the lowest degree. We'll get to what degree means momentarily. And then that leading coefficient is the number in front of the first term when it's in standard form. When we're talking about the degree of a monomial is adding up all of the exponents. So if I just have a number, such as 5, the degree is going to be 0. There's no variables to have exponents. If I have 5x, I would say this has a degree of 1. The exponent on the x is 1. If I had 5x to the 7th, I would say that's a 7th degree. If I have more than one variable, so let's say x, y, and z to the third, I have to add up all of the exponents in that one term. So this piece right here would be a 5th degree. And then when you have a degree of a polynomial, you look at each monomial individually and pick out the biggest one. Some of the degrees have special names. The important part is that you understand the number part. The names are not quite as important, but you need to know what those numbers mean. So, identifying polynomials. We've got 4y minus 5xz. So first off, we're going to look. There's two pieces. So it's going to be a binomial. The degree on this is 1. When I add those up, the degree on this is 2. So I would call this a second degree binomial. Next one, we've got negative 6.5. That's just a number. So we're going to call that a constant. We don't talk about the degree of numbers because the degree is 0. Next one, we've got 7a to the 6th plus b to the 9th. We've got a degree here of 6 and a degree here of 1. So we've got a 6th degree binomial, as you can see from part A and part C. Even though they are both binomials, they're a different degree based on the exponents. And then looking at this bottom one, 6x to the 3rd plus 4x plus x plus 3. Notice in the middle here, we have like terms that we can combine. So we've got 6x to the 3rd plus 5x plus 3. So then this becomes a degree of 3, a degree of 1, and then our degree of 0. So we would call this one a 3rd degree trinomial. If it is something bigger than a trinomial, so for example, if you had something like 9x to the 4th plus 7x to the 3rd plus 3y plus 4, and there are 4 pieces, again, you would look at the biggest degree. So in this case, my biggest degree is 4, and I would call this a 4th degree, and then I would just use the word polynomial because there is no specific name after we get to more than 3 terms. Go ahead and identify these two on your own. We've got a 3rd degree trinomial up top and a 4th degree binomial on the bottom. Next thing we're going to talk about is putting these polynomials into standard form. In order to do that, the first thing we need to do is identify the degree of each individual monomial. So if I'm looking at the first one, my degree here is 1 because the exponent is 1. The degree of the second one here is 1 and 1, giving me 2. Then we've got a degree of 4 and a degree of 3. In standard form, we need to put it from the highest degree to the lowest degree. So the term with the highest degree was negative 2y to the 4th power. This negative is attached to that number. So we took care of that one. Then we're going to go to the next highest, which was negative 6y to the 3rd. And then we've got negative 9xy. And finishing up with a positive 5x. So that's putting it into standard form. And when we're in standard form, it can be helpful to identify our leading coefficient, which in this case is negative 2. It's the number in front of the monomial with the highest degree. Go ahead and try this one on your own, putting it into standard form and identifying the leading coefficient. So we've got negative 24y to the 7th plus 8y to the 5th minus 19, and our leading coefficient is negative 24. So now that we've done all of this identification process, we're going to go ahead and start adding and subtracting. The key thing here is that when you are adding or subtracting polynomials, the degree of each monomial you're adding or subtracting has to match, and the variable, so what that is essentially saying is that the variables have to match. So if I look at this first polynomial here, we've got a trinomial in this parentheses. I've got a 2x squared, I've got a 5xy, and I've got a negative 7y. It says that we are adding. So we're going to go ahead and add on whatever we have in the second one. I've got a polynomial over here with 4 terms. This first one, this 3y, I come over here and I look and I see that the y matches with the y. And then I've got a negative 4x squared. I've got a positive 6xy. And then additionally, I have a positive 5x. So that didn't have anything to match up with from the first, what am I trying to say here? Trinomial. So there is nothing to add it to, so we're just adding it. So now I'm going to go ahead and add these across. I've got 2x squared plus negative 4. That's going to turn into subtraction, giving me negative 2x squared. Then I've got 5xy plus 6xy, which is going to give me 11xy. Then I've got negative 7y plus 3y, which is going to give me a negative 4y. And then I have nothing plus 5x, which is going to give me 5x. My last job is to make sure that this is in standard form. So I'm going to go ahead and say, all right, this has a degree of 2, degree of 2, degree of 1, and degree of 1. If they have a matching degree, it doesn't really matter what order they're in. So I'm going to go ahead and leave them as they are written. And my final answer is negative 2x squared plus 11xy minus 4y plus 5x. And this would end up being a second degree polynomial. Go ahead and try adding this one on your own. When you add it up, each separate piece gets added, and we end up with 3y to the third plus 4y squared minus y plus 3, giving us a third degree polynomial. Process for subtracting is the same as adding, so I'm going to go ahead and start by listing those terms of my first trinomial. So I've got 8ab, I've got a negative 10, and I've got 5b squared. Then we come over to our second part, so now we are subtracting everything. This first one, we've got subtracting 7, so that matches up with the negative 10. We've got subtracting b to the third. There is no b to the third in this first part, so I'm just going to put subtracting b to the third down at the bottom. I have plus 12ab, but remember that's a positive 12ab, so now I'm subtracting that off. And then there is nothing that matches up in that second trinomial with that part of the first one. So I'm going to go ahead and do my subtracting now. I've got 8ab minus 12ab, giving me 4ab. Negative 10 minus 7, giving me a negative 17. 5b squared minus nothing is 5b squared. And then I've got nothing minus b3, so I've got a negative b3. That leaves my final answer then, making sure we put it in standard form. We've got negative b to the third, our highest degree. Then we've got, that should be a negative for a b. Then we've got a positive 5b squared and a negative 17, giving us a third degree polynomial. Go ahead and try this one on your own. Again, lining up the terms from the first with the terms from the second, doing that subtraction, remembering that subtracting a negative turns into a positive, and then putting it into standard form. Last thing we're going to do is go through a word problem. An electronics store is starting to track sales of cell phones and iPads. The equations below represent the number of cell phone sales and the number of iPad sales in a certain number of months. It asks us to find an equation for the total. Remember, total means addition, so we want to combine our two sales. So my first polynomial gives me 4m and 78. I'm combining them to find the total using addition. My second polynomial gives me a 7m and a 137. So when I add those up, I get a total of 11m and 215. So your total equation is going to be total is equal to 11m plus 215. And then it asks you to find the cost for 10 months. So I want you to go ahead and find the cost of 10 months on your own. In order to find the cost of 10 months, you're going to plug 10 into your equation. And when you do that, you end up with a total sale of 325 devices. Between the two different devices, that's how many they are selling. If you have questions about this or anything else from the lesson, please let me know when you get to class.